Hello everyone, my name is Jietian Chen from CSIO Data 61. Today I will present our Tozen paper, Prompt Sapper, an LLM empowered production tool for building AI chains on behalf of my co-author, Yuchen, Qinghuang, Zhenchangxing, Xiwei Xu, and Qinghua Lu. Foundation models like GPT-4, Large Llama, Cloud, Gemini have shown great potentials in different domains. They can support different tasks like answering legal questions, writing code, supporting end user to use their mobile application. With these powerful models, we find that there is a gap exists for the non-technical people to actually develop an AI service based on their requirement. This foundation model would normally provide chat-based interfaces to enable straightforward use of their service. However, this interface suffers from reusability issues. People need to repeatedly talk to the service for the same task. The situation gets worse when the tasks get more complex. Many frameworks have been produced to support the development of the AI services, like Cool AI, Longchain, addressing the reusability issues. However, they require extensive programming expertise, which creates a natural barriers to non-technical users. In addition, some AI chains methods have been proposed to democratize the use of this powerful model through form filling and visual programming techniques. However, several challenges regarding to the task decomposition, prompt design, evaluation, and management remain. To mitigate these research gaps, we first systematically review existing AI chain work, summarize, refine, and extend the concept of the AI chain by incorporating the best principles and practice that have been accumulated in software engineering for decades into AI chain engineering. We built a comprehensive AI chain methodology, and based on this, we developed a block-based visual programming IDE, Prompt Sapper, that enable non-technical users to develop their own AI services. Let me first briefly introduce our AI chain methodology. We first define three basic concepts of the AI chains, namely AI chain requirements, workers composition and cooperation, worker roles, and prompts. The key of the AI chain requirements is to align the task needs and the problem understanding with the model capabilities through iterative design, evaluation, and improvement of AI chains and prompts. Normally, an AI chain will consist of a set of cooperating function units, which we call workers, knowledges to objects. This worker would have their own responsibilities and work together to achieve the ultimate goal of the AI chain. We also introduce a magic enhancing magic strategy that utilizes the large language models to assist the development process of the AI chain. In addition, we systematically define three key activities from the AI chain system design, AI chain implementation, to AI chain testing. Based on this methodology, we developed our Prompt Sapper, an IDE, which embed the methodology naturally to assist the AI engineering to develop their AI chain. So our Prompt Sapper consists of two main views, a design view and a block view. The design view aims to support the main activity of the design phase and plays an important role in bridging the gap between the exploration and construction phases. It has two functions, requirement elicitation and the AI chain skeleton generations, which are supported by two separate co-pilots. Block views can support the AI chain implementation, execution, and the debugging. We also maintain an artifact management system that can manage the different projects, prompts, and the engine. Let me walk you through an example of the use of our prompt sapper. So at first, this is the design view. On the left side, you can see the user, the AI engineer, can prompt some initial idea of their AI chain. For example, they may post like, I want automatically generate questions. So based on this initial requirement, our prompt Sapper will ask questions regarding to this AI chain's requirement so that it can help the user to elicit the more detailed requirement. So as a reply, Sapper said you need to consider what type of the question to generate. For example, questions about the current events, question about a specific topic, question about a particular person. And the user reply with a multiple choice math question. Through the iterative conversation, the user can gradually learn the true requirements. And in the middle, on the top, our system will also constantly summarize the whole conversation into a concise summary. So once the user are satisfied with all the requirements and are ready to generate the AI chain, you can click the button A here, generate AI chain skeleton, and our compiler will help with generate the code. As you can see on the bottom here in the middle, each block is represent one worker, and they are responsible for different subtasks. The user can modify the task of the worker and the input and output in worker. They can also change the order of the worker. So if they are satisfied with the generated AI chain after modification, they can click the generate AI chain. So it then goes to our block view. Our block view enable more fine-grained modification of the generated AI chain. It supports the common control unit, for example, the input, output, if else, loop, and so on. While the visual programming method, the AI engineer doesn't need to know much about the programming knowledge. They can using the drag and drop method to control and modify the generative AI service. And we also provide a testing unit. You can see in E here, there is a green icon, which can show you the current testing area. So once the AI engineer is satisfied with the overall structure and the implementation, they can directly download our code and then deploy it to their service. So in terms of experiment, we conduct several user studies to evaluate the effectiveness of our proposed technique compared to the native programming tool Python. We also conducted several user studies to evaluate the different modules of our system. I will only go through the first user study given the time constraint. So for the comparison experiment, we consider three methods. The first one is Sapper. We turn Sapper v2. And the second one is ablated version of Sapper, Sapper without design view. We turn Sapper v1. And the last one is the baseline, Python, using the PyCharm IDE. We invited 18 participants to join our user study. 10 of them are novice programmers, 6 are beginners, 2 are experts. So in terms of the procedure, each participant will use the 3 tools one by one in the counterbalance order to develop 3 different AI services of similar difficulties. An example is to developing a question answering robot. After they finish this task, we will ask them to answer. They will be asked to answer a usability questionnaire, which consists of several questions, and they only need to rate them from 1 to 5 score. We also recorded the time spent for each task with each tool, and also we record the correctness. So here shows the result of the time spent and the correctness. As you can see the table here, Sapper is easier to understand and use, requiring less time than the native Python. While there's no significant difference in terms of the correctness, but we noticed two findings. First, when using Python, participant is more prompt to produce some basic error. Second, participants will struggle to locate the correct large language model API from the vast documents when using Python. While our Sappers directly provide a form filling method, they don't need to worry about and they don't need to try to locate the API through the large documentation. So in terms of the usefulness, as you can see on the right side, the bar chart, Sapper V2 also outperformed Python for all usability metrics, which prove the usability and the effectiveness of our Sapper in helping the non-technical people to develop AI trends. So in terms of the future world, we have two directions. As we know, there are many mature software nowadays. People will not directly drop the existing one and jump to and use the new one. So I think within the key direction we need to consider in the future is how to integrate the AI chain methodology into existing traditional software and the machine learning practice. The second direction is regarding to the vast design space of the prompt engineering and the emerging capability of foundation models to maintain the stability and the effectiveness of the AI chain. So how to test the generative models given these different factors is also our future work. So thanks for listening, and feel free to ask me any questions through the email.